Here is a square, and it is surrounded by 4 identical right-angled triangles inside and outside of it. If you were to connect the 4 peaks of the triangles together, interestingly, it will form a straight line. But why is that? You can pause the video right now if you want to figure this out on your own first. Otherwise, keep watching, and we will find out why this is the case. Alright, so in order to understand how to prove a straight line, let's first look at what isn't a straight line. So if you have 4 points lined up like this, and you connect them through, you can clearly see there is a bit of a change in angle. So angles A, B, and C will not be exactly identical to each other. So the key to making this a straight line through all 4 points is by ensuring the angle on each of the 3 segments are the same, and we can call this theta. Now there are multiple ways to prove that this is a straight line, and today we're just going to go through 2 different ways, one involving angle theorems and the other one involving trigonometry. In both cases, we'll be using the Tetra shape outlined in black to find our proof. So let's first define the corners of the Tetra shape. Focusing on the bottom left corner, the square will have a right angle or 90 degrees. And the triangle inside it could have any angle, but to make it easy to understand, let's say it's 30 degrees. This means you will have 60 degrees left above it. And the triangle on the outside is identical, so it will have 30 degrees on that sharp corner. So adding the top 2 angles together, 30 plus 60, gives you 90 degrees, making it a right angle inside the tetris. This will be true for all the other corners as well, because we'll use the same angle calculations with the same identical triangles. The next thing we're going to do is rotate the shape a little bit, ignoring the blue square. Take note that the Tetris shape is built off the right angle triangles, which are all identical to each other or congruent, meaning that all their edges match each other somewhere in one place or another, and I'll call these lengths A and B. To make a straight line through the points A, B, C, D, we need to get these angles to match each other. So first we're going to use the angle theorem method to prove that these angles are identical to each other. And one of the most useful theorems to use here is the alternate angle theorem. Every corner has a right angle, meaning these lines are parallel to each other. So the angle at A will transfer to the angle at B, which also then transfers through to the angle at C using alternate angle theorem, meaning those two are the same, or we can call them theta. It is the same case between point C and D, because you can use opposite and alternate angle theorems to prove that these 2 angles are also theta. And this sufficiently proves that it is a straight line. But I say sufficiently because one might ask, what is the angle of theta? And this is where the trigonometric proof comes in, because this will prove it with absolute numerical accuracy. Pluck out the triangle at the top, and take note that both its edges are the same length of A. The tangent of theta can be calculated using SOHCAHTOA, so you can take the opposite length divided by the adjacent length. This is A divided by A, meaning it equals to 1. And so to find theta, you take the inverse tangent of 1, and this will give you 45 degrees. The triangle between C and D is identical to this, so we expect that angle of theta to also be 45 degrees. However, the triangle between B and C is different in size, so we need to get those lengths first. The height of the Tetris shape is A plus B, while the base is B plus A, which is the same thing. To get the bit between B and C, you must minus off these 2 bits, which is just A and A. So taking A plus B minus A gives you B minus A, and this is the same for both the base and the height of this triangle. Since they are the same, the tangent of theta here will also be equal to 1 because they divide each other off. So theta is also 45 degrees here, meaning all the angles are the same, which proves that all 3 segments form a straight line through the points A, B, C, and D. And there you have it. A very interesting coincidence that occurred as a result of using identical right angle triangles around a square. So that's all I have for today. Let me know what you think down in the comments below. Hit the like button if you found this video interesting, and click the subscribe button to join the channel. Thanks for watching guys, have a good one, and I'll see you next time. Bye for now.